Hello everyone, welcome back to my YouTube channel once again. So in today's session, we are going to discuss something about development length. Okay, so development length is a length which is provided at a junction of beam and column. So here are some points I have noted down. So we are going to discuss these 4 points in today's session. So first one, which is very important, is what is development length. Second one is why we provide it. Okay, why we have to provide the why, what are the reasons. Okay, so that also we are going to discuss here in today's session. Factors affecting development length. So what are the factors which are going to affect development length? That also we are going to discuss here. How to calculate it? So there is a formula to calculate the development length. So that also we are going to discuss in today's session. Okay. So first is, what is development length? First is, development length is the minimum length of bar that must be embedded in the concrete beyond any section to develop its full strength. So in this particular image, you can see that the column and beam, there is a junction of column and beam, and LD, the denotation which is given over there, is describing you that we have provided embedded length, some amount of embedded length in that particular column, and you can say the amount of development length or the amount minimum length, whatever we have extended beyond that particular cross section, is nothing but the length we are going to provide as a development length. And that is what is very important, actually, the chapter. Okay, so in the reasons, we will again understood this in a brief manner. So development length is the minimum length. A definition of development length can be described as the minimum length of the bar that must be embedded in the concrete beyond any section. Okay, so to develop its full strength. So the next is why we are going to provide the development length. What are the reasons? The first very basic reason, to develop a safe bond between the bar surface and the concrete. Okay, we have to develop a safe bond between your the bar surface and the concrete. Okay, so when we are going to anchor that amount of development length in that in the junction, that time it will ensure that there is a safe bond between your bar and the concrete. Okay, due to slippage, the second reason is due to slippage of bar. Due to slippage of bar, sometimes bars can be slipped, and that time during ultimate load conditions, no failure occurs because you're going to anchor that particular amount of length in you can say the extended portion, and that's how that will be attacked, that will take care of that failure. Okay, so that not there should not be any failure, we can say. Okay, so failure will not occur if you are going to provide the development plan for transferring the stresses developed in any section. So we are going to use the development length also to transfer the stresses from one section to other adjoining section. Then the extra length of bar provided as a development length is responsible. For example, at this column and beam junction, you can see whatever is the embedded length, whatever is the additional length we have provided between beam and column, that will transfer load of beam to the column. Okay, so that is very important scenario. You can see in this particular picture. Can you see? This is the picture. Okay, now we will discuss the factors that are affecting the development length. So the very first factor which is affecting the development length is compressive strength of concrete. So if the compressive strength of concrete is less, the development length required will be for the bars will be more. Okay, so if more is the compressive strength, then less would be the required development of bar, and if less is the compressive strength, the bar development will be more. So this factor is inversely proportional. Okay, so compressive strength of concrete is inversely proportional to the development length of the bar. Okay, so in short manner we can describe this. Okay, density of concrete. Second important factor is density of concrete. The development length must be increased if lightweight concrete is used. Okay, so it is very simple to understand. Rebar clear cover. Whatever the clear cover we are providing in beam, in column, if the clear cover is increased, the length will decrease, and if the clear cover is increased, this length will decrease if we increase the clear cover. So this is also inversely proportional. Rebar center to center spacing. More concrete will be available for rebar to resist horizontal splitting if bar spacing is increased. We are going to increase the spacing. Okay, so more concrete will be available for bar to resist the horizontal splitting. Okay, so you can increase the center to center spacing. Now, second, the last important is coating of rebar. In some projects where the structure is subjected to corrosion, environmental conditions, you can say, there epoxy coated rebars are used, and in such cases, the bond strength between concrete and rebar is reduced and thus requires more development. Okay, so this is also one of the important parameters you can write here. Okay, so now lastly, the formula which we are going to use to calculate the development length is LD is equals to 5 sigma S divided by 4 tau BD, where 4 is the constant. Only 3 terms you have to calculate. LD is nothing but the embedded length of steel bar. However, we are calling it as development length. Sigma S is permissible stress in steel, which is given in table 22 IS 456, annexure B. Tau BD is a bond stress which depends upon the grade of, that depends upon the grade of concrete. Okay, so you have to calculate it based upon the grade of concrete, that is compressive strength of concrete. Now, phi is the diameter of bar which you are using. So that's how these parameters you have to calculate. Okay, so in today's session, we have covered up the topic that is development length, under which we have covered 4 topics: the definition or the what is the development length, the basic definition of it. The second was why we are going to provide it, that is the reasons why we provide the development length. Third one was factors affecting the development length, and the fourth is formula. Now, in coming sessions, we will definitely discuss many more things related to the RCC or designing parameters. Okay, so stay tuned with my channel, and hope you guys like my video. So if you like my video, please like, share, and subscribe. Thank you, guys.